So steps to be taken for implementing smart farming in India. So this is the thematic topic that is given to me. And what is this smart farming, or how can we define the concept of smart farming? See, smart farming is best best farming techniques that involves higher and advanced productivity with existing farming practices. So this definition is somewhat so technical in nature, but in short, I would like to tell you that smart farming refers to the use of modern day technologies. So we have different modern day technologies nowadays, like IoT, big data, artificial intelligence, wireless networks, etc. So taking the help of these modern day technologies, you are going to enhance the productivity, quality, and overall efficiency. See, whenever we go for the term smart farming, these three steps like productivity, quality, and overall efficiency have to be taken care into considerations. That's why many countries have adopted these technologies, especially the countries like USA, Japan. Okay, USA and Japan, they have adopted these technologies, and whereas the countries named with Nepal, India, and Bangladesh, they are adopting these technologies. So in the process of these adopting these technologies, they are facing some problems. So being the engineers, our main intention is not only to give a solution, but we are supposed to give the solution whenever any problem occurs. And one more thing here, what is going to be happen here is that yeah.
Vivek, sir?
Yes, ma'am. Can you hear me?
Yes, sir.
Ma'am, is it okay? Everything? I think there is
Yes, sir.
some signal problem, I think so.
Yes, sir.
So as I told you that the developing countries like Nepal, India, okay, Nepal, India, and Bangladesh are facing some problems. Okay, only a little sort of problems they are facing in implementing these smart agriculture practices. The main reason is of due to the geographical, technological, and economic constraints. And I would like to introduce you to one important game-changing technologies in this smart farming. It's mainly based on, especially on the area of agriculture, like chatbots and robots. See, chatbots are commonly used to automate customer services. And I would like to say you that chatbots can be a convenient interface for accessing the information. So here the farmer can access the information about a crop or a livestock conditions. And chatbots are also used to advise the farmers on irrigation and fertilizations. And not only they help the farmers in these irrigation and fertilizations, but they also assist the farmer in doing the financial planning and management. So that much of importance is there using these chatbots in the agriculture aspects. Now coming to the robots. So as we know that agriculture robots are used in smart agriculture. Okay, for accomplishing the tasks like crop monitoring, planting, and harvesting. And even by using these robots, we can also use to apply pesticides and herbicides, especially to the water plants. Agricultural robots are also going to be controlled remotely. And I would like to say you that both of these chatbots and robots comes under autonomous in nature. So the main intention the main intention behind this smart agriculture is to find the solutions for the 3 steps. Like we are supposed to enhance the productivity, okay, and quality and overall efficiency. And let us see the smart farming, some of the smart farming software related application areas. Okay, so in the first application area, with respect to software, I'm going to speak about the monitoring climatic conditions. See, climatic conditions plays a most crucial role in crop production. Due to the lack of knowledge about the crops and their growing stage, these climatic conditions leads to catastrophic results. That is a reason where the smart agriculture technologies enables the farmers to receive real-time data about different climatic conditions by taking the help of various sensors. And these sensors are located across the fields, and they are also kept on the crops wisely. And I would like to say you that the measurement between these 2 sensors is also very much important, because sometimes what happens here is that these sensors will overlap each other, and chances are there that the farmer may not able to get the appropriate information. But there is one big advantage with this. Okay, if you enable or if you enable the IoT system, okay, this IoT system sends the alerts for any unusual changes in the environmental factors. So whenever there is a change in the environment, it will caution the farmer to take precautionary measures. So that's why monitoring the climatic conditions became one of the important software related application with respect to the area of smart farming. Now, if you see the second application, we have seen about this precision agriculture, but in the second application, we are going to see what is precision farming. See, this precision farming is also a smart farming strategy which increases the operational precision by providing each plant and animal exactly what it needs to develop in best possible way. It not only concentrates on the plants, but also on the animals also. Okay, so what is the output we are going to get here is that it will maximize the overall performance while decreasing the waste, inputs, and pollutants. This is the main advantage of, means the main output of using this precision farming. But here also, again, we are going to take the help of Internet of Things, IoT, where the combination of IoT sensors means by taking the help of the combination of IoT sensors, the farmer can precisely identify the amount of water, fertilizer, pesticides, and other resources while decreasing the cost. That is the main benefit and output what the farmer is going to get here. And the farmer is going to get the output especially on this aspects only. Mostly he focuses on mostly this precision farming focuses on the amount of water, which is very important, that how much quantity of water has to be given to the fields. Okay, and what is the fertilizer to be used, and what are the different pesticides followed with other resources. So by adopting all these things, okay, what will happen is the farmer can able to decrease the cost. So this is about the precision farming. And if you see the third application, which is very, very important and speaks about the greenhouse automation. See, I would like to tell you a very good example of this greenhouse automation. Recently, in Hyderabad, we know that we have Ramoji Film City. So inside the Ramoji Film City, if you go, there are many more plants, okay, where he concentrates much on plants and animals also. So there is one place where he kept like butterfly butterfly plants, and he's going to adopt this greenhouse automation. With the help of this greenhouse automation, he is going to see that the different types of butterflies, okay, are going to stay in one place, and at any environmental conditions they won't come out, even though the door is open to some extent. Okay, so those butterflies of different families will never come out. So greenhouse automation not only concentrates on the farming, but also here the farmers. Okay, usually we know that farmers used to follow the manual procedures to control the greenhouse environment. But with the IoT sensors, the real-time data can be collected, and the control mechanism can be implemented to maintain, such as lightning, temperature, soil condition, and humidity. So these are the four factors. Okay, four important factors what the farmer is going to attain if he is going to take this greenhouse automation. So these four factors are very, very important as far as this greenhouse automation is concerned. Such as he mostly concentrates on the lighting. Okay, that means how much light has to be given. Okay, how much light has to be given by taking the help of different types of LED bulbs, or by taking the help of sensors. Clear? And what is the temperature? Okay, even the details of the temperature are also given to the farmer, that at what temperature it has to be done. And the soil condition, this is also very important. See, depending upon the soil only, okay, it is going to tell that which crops or which plants may come, and how much time it will take to come into the overall format. And as well as humidity. Humidity is also one of the important factor that is considered in this greenhouse automation. See, all these, okay, whatever I'm going to talk, like precision farming, monitoring agriculture, monitoring climatic conditions, greenhouse automations, directly or indirectly, this is going to play the most important and crucial role with the farmer. Not only on the crops, not only on the farm fields, but also on the animals also. So once, if you see the fourth application, it speaks about, okay, it speaks about the monitoring of livestock. See, what is going to happen in this monitoring of livestock here is that the sensors are attached to the animals. Okay, and these animals are there on a farm. And by using these sensors, okay, the person who is going to take care of these animals can able to monitor what is the health condition and what is the movement of that animal. That means to some particular area where it is going, okay, and what is the exact location. See, these three are the most important things, like monitoring the health condition, movement, and location. Apart from this, the sensors will give that a person, okay, some other information, but with that information, these three points need to be satisfied. And it also helps the farmers to identify the sick animals. And not only it identifies the sick animals, but also gives, or it also tells the farmer to take preventive measures to control the spread of that problem. And you know, the most important output what you are getting from these monitoring the livestock is that it minimizes the labor costs, as the animals can be tracked remotely. In the place of keeping 2, 3, or 4 persons in charges of taking care of some set of animals, it is better upon implementing this livestock. Okay, so it reduces the labor costs, as the animals can be tracked remotely. If you can see this picture here, so on the animals, nowadays we see that the cows, usually on the right ear or left ear, they have some sticker in the form of yellow color. Okay, it indicates that these cows have been taken in the form of a loan. Okay, I mean the animal loan, like personal loans. But in these sensors are also placed on the ears, especially on the ears of the cow, to trace the movement. Okay, and the movement is going to be absorbed by the nearest sensor. So monitoring the livestocks mainly focuses on the health condition of the animals or the crop, mostly on the animals movement and its location. And the next important application which is related to the software area is that remote sensing. Remote sensing techniques, we have lot of techniques in this area of remote sensing. Remote sensing techniques, these techniques are used to collect the data for analysis, and these analysis are going to be done by using some analytical tools. And these analysis also helps us, okay, in monitoring the crop assessment, weather conditions, and soil quality. See what is the grade of the soil? What is the grade? Like soil grades are classified into 3 types, like Class A, Class B, and Class C. And you know, Class A gives us the highest output. What I mean to say is Class A gives us the highest or the maximum profits. Class B will gives you the 75%, like 75% of the profits. But whereas the Class C only focuses only on the 30%. That means once if you came to know that the soil comes under the Class C, immediately the farmer should take the help of these type of software related applications, and he or she should choose which plant will be suited for this soil quality. And using as the technology has been improved nowadays in this 21st century, I would like to say you that the applications came in such a way that if the soil is in the Class C, okay, immediately it is going to give the farmer the information that this crop or this plant is best. And it also gives the information that to what extent that plant or crop will come, and what is the area, okay, to such area, how much profit can be generated, and what are the different problems that he might encounter while doing this process, and how to overcome those problems. Everything will be given by using present technologies. So these are the 5 important application areas which are purely related to the software. And if you carefully observe these 5 application areas, see, directly or indirectly, we are going to use the sensors. Okay, and directly or indirectly, all the sensor data is collected into one place. Okay, and we are going to, especially whenever you hear the word of sensor, okay, almost we get in mind that it comes under one part of IoT. Now, let us see what are the different challenges that are going to be taken in this smart farming with respect to hardware. So up to now, you have seen about the software challenges, I mean software application challenges. Now let us concentrate on the hardware. See, IoT devices, okay, see, or any sort of hardware devices which we are using are going to be kept in the rough environmental conditions, such as like examples like sunlight, strong winds, heavy rainfall. And whenever you are going to keep the sensors in these type of conditions, what will happen? Chances are there that they may destroy the devices. Okay, so the main goal of an engineer, or the main goal of us, is to see that these devices should be active most of the time, and it should regularly send the data with low power consumption. So it should regularly send the data. This is one aspect. Okay, and by taking the goal of low power consumption, hardware requirements are more and more challenging. Okay, even though we have more like software requirements are also challenging, but on compared with the software and hardware, both are challenging in nature. Both of them are having equal priority, and both of them has to be given the equal importance also. Okay, now what are the different challenges that are faced in smart farming with respect to hardware? Okay, there are many challenges here. So the first challenge, what we concentrate here is about the connectivity issues. See, the farmer is going to work with the technologies, okay, or with the upgraded technologies. For efficient working of these technologies, okay, IoT devices use different connectivity protocols for what to send the data to the servers. And in the remote areas, there might be some issues with the wireless connectivity also. Okay, our aim is to see that, okay, especially in this connectivity issues, okay, being an engineer, our aim is to see that these networks, these networks are also available in that places, okay, which is are also available in the places where the difficulty of transmitting the real-time data is not possible. That means we need to design, or being an engineer, we need to design the hardware in such a way that in in the rural areas the connectivity will be less, but the device should be constructed in such a way that it should work at least like I can tell you that once the data is sent, okay, at least the data should reach to the server, or the data that is coming from the server, at least even though if there is any time gap also, it's not a problem, but the time gap also should not be more. That means suppose now at this moment I send some data, okay, and it will reach to the destination part within 2 to 3 minutes. So 2 to 3 minutes is not a big problem, because we are the receiver is in the place where there are less connectivity issues. Okay, next, the second important hardware consideration what we need to take here is cost, because to implement a smart agriculture, okay, especially which focuses on modern farming practices, okay, the hardware costs are also very high. And as you know that nowadays we are getting the IoT devices of less cost, even though the prices have fell down. Okay, so it requires a significant cost to implement high quality sensors and actuators. Even though the price has fell down for one hardware, but the price for the another hardware is getting increased, because you are going to use sensors, and those sensors should come under high quality. Suppose the cost of the high quality sensor is less, the cost of the actuator is becoming more and more. And one more thing, apart from this, big data and analysis, okay, to perform the big data analysis on different servers or cloud storage or farm management, okay, to implement these applications, the software cost is becoming very, very high. So that's why cost is one of the important term, or the important challenge that has to be taken, not only in hardware perspective, but also with respect to software perspective also. Because the cost that is incurred in designing the hardware, the same cost is also incurred in designing the software and giving it to the stakeholders. And the next one is security. So we use different IoT devices. Okay, the agricultural technologists or horticulturists or a farmer, okay, are going to use these technologies like IoT devices. Okay, so security is also going to play the most important role, because precision farming and IoT technology work with large set of data. Okay, so maintaining and storing those data with high security is a very tough task. And sometimes what happens is these IoT devices, servers, and these autonomous, like automatic or autonomous robots are also prone to cyber attacks. So chances are there that these might be attacked. So maintaining good authentication, privacy, data protection, and resistance to cyber attacks is a challenging task. So one has to satisfy, or one has to satisfy all these properties, like the design should be highly authenticated in nature. It should be it should have a lot of privacy. The data protection should be there, because the data is sent from cloud servers to the farmer or to the stakeholders. And the combination is that all these three should be resistant to cyber attacks. That's why the cost as well as security are termed as very important. Even though, see, connectivity issues, by taking some extra elements, you can able to overcome that. But cost and security is not like that. It purely depends on the manpower of that person. He has to be very authentic in designing or in achieving these goals. And next one, or the next challenge, what we have here is that interoperability. So interoperability mainly concentrates on the different components, okay, has to work on a system together. So as you know that in smart agriculture, various modern technologies are integrated to provide an agriculture solution. These components may operate using different protocols. So each and every component is designed using different protocols. And each and every component is designed on different machine architectures. That is the reason it is a challenging task to connect these components and interact with each other. For example, okay, if you are not clear with the concept of these interoperability, protocols, see, we are going to use the protocols for the sensors. So protocols used by the sensors, or protocols used by the cloud storage devices, or protocols used by the servers, or you take the protocols used by the AI technology, and the protocols used by the end devices. That means the device which the farmer or a particular stakeholder is having. All these are purely different in nature. So interoperability is also one of the challenging hardware mechanism. And there is one more important challenge here, is that education and training. See, education and training, due to the lack of proper education and training, okay, to operate that device, smart agriculture technologies are facing a major issue and challenge, especially in the developing countries. So why I'm telling you is that many farmers from rural areas and developing countries are unaware of modern technologies, and they don't know the way to operate them also. So the best solution in this education and training is that we need to enhance and flourish such technologies for next generation farming. Proper up-to-date training should be given, along with the how technology is going to be implemented for his or her sustainability. So the main focus, okay, that the main focus for the next generation is that we need to flourish such technologies for the next generation farmers, and proper up-to-date training should be given. So why I'm telling you here is that, see, training means they come and they will explain that you are supposed to click on this button, that button, and then this output or this window will come. That is not a training. See, training means sometimes what happens here is that in the middle of the work, some error or some bug may encounter. At that time, the stakeholder or the farmer should know that, okay, to overcome this bug, okay, can he able to apply his education and application to overcome that bug, or at least he should know, okay, whenever he gets a bug in the device, how he need to get the information to contact the specific engineer. That is also most important. That's why giving training and education and coming is not only the criteria. The stakeholder or the farmer has to react to the bugs in the middle of the work also. At least if he is not in a position to react to the bugs, at least he should know the options where he can able to get the engineers who can resolve this type of bugs. Now, let us see the next important and interesting application in smart farming is about robotics. And you know, robots nowadays are used in smart farming, especially, okay, the robotic arm is going to harvest the crops. It's going to harvest the crops. I'm telling you, a very good and real-time example is there is a name, the name of this robot is Panasonic tomato picking robot, which is present in Tokyo, Japan. You know, the main specialty of this robot, if you see the images here, this robot is going to pluck, okay, the tomatoes, okay, which have purely like, it's going to see the nature of the tomato, whether it can be plucked or not. So which tomatoes need to be plucked and which tomatoes need to be plucked after 2 days or 3 days, it can able to recognize. So you can see here, okay, the robotic arm, it's just a robotic arm, which is going to pluck the tomatoes here. Okay, and after plucking these tomatoes, it is going to put up these tomatoes in the basin that is available under this arm. So the name of this robot is Panasonic tomato picking robot. And you know, till today in the Tokyo, the farmers are going to take the help of these robots. And do remember, robots means don't think that you are supposed to design a robot from head to legs. Okay, toy. It's wrong. Even if you design one arm that is also a robotic. You can call it as a robotic arm. And even if you design one leg, okay, one leg, it is also it's also called as a robot. Okay. So you can see the pictures here, the Panasonic tomato picking up robot, and this technology is also going to come in India. Okay. And probably within 1 year or couple of years, you will see a drastic change in the farming. You will see a drastic change. And the second one here is that you can see the tea leaves picking robot. You know, there is one robot which picks the tea leaves. So it scans the size of the plant and it sees that whether the plant size can give the information to pick the tea leaf or not, tea leaves. So this is the internal architecture of the robot, and the speciality of this robot is that it picks the tea leaves depending upon the size of the plant and the condition, okay, the health condition of the plants. And you know, these type of robots like tomato picking robot and tea leaves picking robots, these are widely used in the foreign countries like in USA and Japan. Japan mostly uses can go there and see literally you will see a lot of changes in the area of smart farming and smart agriculture. So this is the actual design of this tea picking robot, tea leaves picking robot. And let us speak about the optimal harvest date. See, in this smart farming or smart agriculture, okay, there is one more important criterion which we need to take care, and which most of the farmers or the stakeholders do not concentrate is about harvesting date. Okay, so why what is happening here is that harvesting date plays a crucial role in the crop yielding. I would like to say you that if the harvesting date is too early or too late, there might be a significant amount of yield losses. That means there might be a significant amount of crop losses. So smart harvesting technologies with the help of IoT and AI, okay, should help to find the optimal harvest date, okay, which by taking this, okay, it eventually increases the productivity and minimizes the losses. Remember, one very, very important is that harvesting date. Harvesting date is also very important. Okay, so depending upon the condition, depending upon the environment, depending upon the climatic factors, okay, climatic factors, the harvesting date will be given. Okay, it should not be too early and it should not be too late also. And the next important aspect, what we need to concentrate is on agrochemical application. See, optimal harvesting date, agrochemical applications, these are the points usually where the farmer will have less concentration, a very less concentration. So what is this agrochemical application? See, agrochemical application refers to the chemicals which are used for controlling the pests and increasing the growth of crops. So examples of the chemicals such as fertilizers, insecticides, pesticides, herbicides. So these are the examples. So if the farmer is going to use these chemicals in excessive content, these chemicals may affect the crop production as well as the environment also. It will totally disturb the environment also. So with the help of the hardware devices, okay, well-known hardware device which we know here is that an IoT device. By taking the help of the hardware IoT devices, it will help the farmer to detect the nutrients such as the nitrogen, phosphorus, and potassium. And it also gives the information to the farmer that how much amount of fertilizers are to be used to get a good productivity or to get a good output. So why means, I would like to say you that these herbicides, pesticides, and insecticides, these are mostly and widely used to control the weeds, pests, and insects. And also, if you try to, if you follow that particular instructions, there is a chance of promoting the plant growth in a very large scale. The plant growth will be in such a way that if you follow the appropriate quantity, especially when the farmer is going to deal with these herbicides, pesticides, and insecticides, if the farmer is going to purely follow the instructions given to him, that means which got to him on the particular IoT device, I can tell you that the plant growth or the soil growth or these smart farming will give him such a good output which he also never can expect it. So so with this, what I would like to say you here is that see, all these like what we call the smart harvesting or the smart farming and these agrochemical applications, there are some parameters. Okay, there are some very important parameters which define this smart harvesting, smart farming. Okay, and I would like to say you that even for smart water management also, see, water management is also very crucial here, because that device, that hardware device is going to inform the farmer that such amount of water has to be forwarded to the field. So there are some parameters, okay, which are going to define all these things, like the parameters like reliability. Okay, to what extent the agrochemical application is reliable in nature. You see, I can quote that the farmer can have a very moderate effect of it. Okay, that means why I use the word moderate here means the losses that are going to be incurred will be very less when compared with the losses when you are going for the traditional approach. And you know, the reliability, and the one more important parameter is about the scalability. The scalability is very high. The scalability is very high in agrochemical applications, as well as the scalability is very high in this harvesting date also. That means the appropriate harvesting date that is given by the device after going through all the parameters, of the soil or of the farm. Okay, so I can tell you that the scalability will be very high. Now coming to the affordability, which is also one of the parameter. So affordability is very low because whenever the farmer is getting this type of options, there the chances are there that maybe not all the farmers can incur to buy such type of devices, or to enable such type of devices. And the security, I would like to say you that the security is also moderate here. Okay, so security is also moderate both for agrochemical applications as well as for these harvesting dates also. So sometimes what happens is, if there is any defect in the device may give the date which is not acceptable. Okay, and coming to the last important parameter, that is nothing but about the usability. Okay, so the usability at present in India is moderate, because now only our farmers are going to think that the adoption of technology is also one of the important and crucial role in their life. Okay, so by going through this, okay, I would like to say you that there are some smart farming ideas which I can give you here. Okay, so some of the smart farming ideas are like indoor vertical farming. This is one of the smart farming idea. Indoor vertical farming. So what is this indoor vertical farming? If you see the picture here, indoor vertical farming, you can say that it is the procedure of growing plants in closed and controlled environments. Indoor says that it deals with the closed as well as the controlled environments. So with this method, I can say you that the plants can be mounted vertically, and it will also take less land space to grow when compared to the traditional farming. So even in a small space, also you can able to grow. So vertical farms mostly does not require the soil for the plants to grow. And the most advantage by using this indoor vertical farming is that the labor force will be reduced. And I would like to say you that this is the best and the first farming technique that is there in our India. I'm very, very happy because I'm very, very happy with it. And I too like this indoor vertical farming. So one smart farming idea is about the indoor vertical farming. And not only the farmers, even we can also do this indoor vertical farming. And the second farming idea I would like to give you here is about the farm automation. So I can say you that this farm automation is the upgradation it's one of the upskilling of farming machines and equipment. So usually this farm automation mainly works on autonomous tractors, automatic watering, developing the drones, okay, and developing different robotics. And not only developing the robotics, but also seeding the robotics. So farm automation mainly focused on 4 aspects. It is going to work on the autonomous tractors, autonomous or automatic tractors, automatic watering to the plants or to the soil, which is very important by taking the help of the developed drones. And taking the robotics innovation into consideration, okay, robotics are also going to seed the plants. So this is one smart farming idea. And just remember, robotics means not full robot, even an arm, even a leg, or even a hand. Okay. And the next idea, one of the important idea is about blockchain. So using this blockchain, the farmers can able to resolve many important issues or the problems, like the problems related to food, the problems related to supply chain inefficiency, the problems related to safety recalls. And one important problem that can be overcome using blockchain is food fraud. This is one very big problem, food fraud. So using this blockchain, okay, you can able to verify the transactions, okay, that are securely shared with the seller or not. So blockchain also provides a good level of security. I can tell you that it provides a good level of maintaining transparency, both in the market place as well as in the food supplying also. So blockchain is also having very good applications in this smart agriculture and even smart farming also. And apart from these smart farming ideas, we have some other ideas like developing the modern or designed greenhouses. Okay. And India is also going to adopt this greenhouse in very large scales. So because designing these greenhouses, it will be very easy for doing the automated control systems. This is the most important output that is achieved from these modern greenhouses. Apart from this, we have many other ideas like implementing the artificial intelligence. But I don't want to touch this AI as you have some idea on this. And next, what are the different benefits of smart farming in India? That means especially I'm focusing in our country. That means what are the different benefits of the smart farming? So the first benefit what I identified, okay, in the real time is increase in efficiency. So by smart farming, farmers can increase their efficiency, like by taking the help of advanced technologies. Farmers can produce more products in a limited time period. And with the increase in efficiency, they are also going to forecast the results that are going to happen in the future. And by taking that results into consideration, they are going to take the important decisions, okay, important decisions on the management. So increase in efficiency is the first benefit which I have identified, okay, in India with respect to the smart farming. And the next one is the proper use of resources. Resources like energy, water, and land. These resources should be used very properly. Because by the time the IoT device is going to collect the data from the sensors, this will help the farmers to allocate an optimum amount of resources to the plants. So proper use of resources is also one of the best benefit in India, which is present in India. And second one is the cleaner process. So cleaner process means these technologies, okay, evaluate the use of taking the fertilizers and pesticides. So, and these cleaner process, the main advantage of taking this cleaner process is that they try to give the organic products, and those products are also very clean in nature. Very clean in nature when compared with the traditional farming techniques. And one last important benefit is agility. Agility, see, sometimes what happens to us is that there might be some weather changes, air quality, humidity, okay, and the health of the crops. All these are going to be monitored by the farmer who is using the technology. See, whenever the farmer is going to use a technology, he is going to get what are the different weather changes. That means, are there any uncertain weather changes? What is the quality of the air? What is the humidity levels? And what is the soil that is present in his field? And also, what is the health of the crops? Okay, that means what is the health of his crop? All these are going to be monitored in one single place. This provides the real-time monitoring that can predict the condition of the crop. And this also provides the professional advice in extreme weather changes that can save the crops. So not only in normal environment, it also provides the professional advice. Okay, and it will never and ever ask you or ask the farmer or ask the stakeholder to jump from one application to the another application. That is where the agility is going to be achieved here. So it mostly focuses on these areas. And with all these, okay, by means like by taking the above all into consideration, like increase in the efficiency, proper use of resources, the cleaner process or the cleaning process, the agility with this, an improved food product can be achieved. An improved quality of the output is achieved. That quality of the output will never be achieved in the traditional process. That output will never be achieved, will never and ever be achieved in the traditional process. See, I would like to introduce you some of the important models. Okay, so as this is one of the important FDP. So with this, I would like to introduce you to some important models that are used in agriculture. Okay, and I don't want to I don't want to present the known models in front of you. Okay, suppose if you take the machine learning into consideration. Okay, machine learning, we have many models that are used in machine learning, but the models what I would like to introduce you is, if any possibility is there, the future research is going on the Bayesian models. The Bayesian models. So why means these Bayesian model can provide accurate, okay, it provides accurate crop yield predictions. You can try using these Bayesian models rather than trying the concepts of like what we have learned, like regression, clustering. Those are the old concepts. I don't want to say like old concepts, but a lot of work is there in this. Okay, a lot of proposals are there on this. So I would like to work on these Bayesian models and also work on artificial neural networks. Usually Bayesian models and artificial neural networks, the work or the research is improving a lot. There's a lot of increase in the research, especially in these models which comes under the machine learning area. And when you adopt to these models, you will get some benefits like you can save the time and the labor, you can reduce the cost, okay, and you can enhance the safety. And it not only enhances the safety by using these machine models and artificial neural networks, but also it improves the decision making, which is very important. And even you can protect the biodiversity also by using these models. And and if you take, okay, if you want me to tell in specific in nature, okay, like in specific in the sense like by taking this Bayesian model, okay, you can also, okay, achieve proper, or you can also achieve high-end food quality. High-end food quality, which is of very, very higher quality. So this is one of the important model, okay, I would like to introduce you. And one another important application of these machine learning in smart farming is that this ML is also now going to concentrate on the nutrients. Nutrients is one of the important problem which is coming in the next coming days. That means the nutrients, proper management of nutrients is also very important, and this can be achieved by using the ML in agriculture. So what I suggest you is to work on these type of models like Bayesian models and artificial neural networks with respect to the nutrients. Okay, nutrients is one of the application, and these are the models. And while you are working with these type of models, you are supposed to see that, okay, you get all these outputs, not leaving even a single one. Suppose if one technique is leaving some sort of disadvantages, it has to be enhanced in the next coming part, or it has to be enhanced in the next coming model. And so traditional farming as well as, okay, and smart farming, both are quite different in nature. Traditional farming as well as the smart farming, both are quite different in nature, and a lot of differences are there, because in the smart farming, you are going to take the help of a geoinformatics system where it captures the hyper spectral images, okay, and takes the help of remote sensing. I mean, it uses the techniques of remote sensing. Okay, so with this, I would like to stop my points here. Okay, so please let me know if you have any queries.
Thank you, Vivek, for your time and contribution. We deeply appreciate to guiding us through this farming. We look forward to more opportunities to learn from you in the future. Thank you once again. Anyone have a doubt?
Yeah, thank you, ma'am.
The second session will start at 7:30.
Ma'am, I'll join at 7:30.
Just re-summarize this architecture. So what we have seen in our previous session, so what we have seen in our previous session, the sensors are nothing but input devices. So there are many types of sensors like temperature sensor, humidity sensor, soil moisture sensor, vibration sensor. So for measuring any physical parameter, we have sensor. Like for color, we have a colored sensor. So there are a lot of sensors are available in the market. So nearly 300 types of sensors are there. So these sensors are connected to processing devices. So these are nothing but basically evaluation boards. So this evaluation board here, you can take example of microprocessor-based system boards or microcontroller-based system boards. If you take microprocessor-based system boards, so what I told you, you can run operating system on top of it. If you take microcontroller-based system, you cannot run operating system on top of it. And if it is a microprocessor, you have to use ADC in between. But if it is a microcontroller, you need not to worry about using ADC because microcontroller will have on-chip ADC. And what I told you that you can code using manual coding or you can use a graphical coding. Okay. So when I say manual coding, once again, you can use a language, say Python, or you can use a language C, or you can use a language C++, or even you can use a Java, or basically you can use any IDE-based support language. In case of this is Arduino IDE I'm using right now. So what is Arduino IDE? We know that it's a development environment where your editor, compiler, basically everything is available for you. And then basically one thing is missing in this diagram. You have to use a gateway in between because ESP32 or Arduino or NodeMCU doesn't have any direct connection to the web server. It has to have an interface router in between. Router is nothing but the gateway which you're using at your home to connect. So for that, you have to configure SSID and password for that. So in the coding, you have to write that logic. That we'll see today. And once you write that logic here, then what will happen? You can upload the data to the server. Now, once again, this cloud or basically a server here, basically clouds are many types. You have Arduino, for example, you have a ThingSpeaks cloud, you have Azure, and you can also have AWS, any where you can push your data. It's up to you, wherever you have an account, or you can create an account. All right, so after this, what else you can do? You can monitor your data. Basically, you can see some visuals. So whatever the data sensors are sending, you can see that visual. On the other side, you can also configure your own web page. If you don't want to, let us say, use any third party, you can also use your own web page. There also you can monitor your data, or even you can control the data also. You can have some buttons to send data. Example, here fan is connected. Let's say to this output device fan is connected, you can control fans. Or similarly, there is a third party, one application is there called Blink, which is helping you to monitor as well as control. I don't have a time to show you the Blink because it's little like one more session I have to take separately on top. So that's something like you can do about it. Okay. So having said that, this is what it is. So what we are going to do in today's session. So today's session, like last session, we have interfaced the NodeMCU and we have seen some graphical coding also. If you can remember, we have also even interfaced one actuator that is LED, and we have interfaced one board called ESP32. Soil moisture sensor to the ESP32. These two we have seen in our last class, correct? So any doubt till this to anyone? Yes, anyone, any doubt? All right. So what we are going to do today? Okay, so today's session will be, let me just take you here. So let me just write down something. So let me take one simple text file and let's write something. So what we are going to do? So today, what we are going to do, we will interface NodeMCU, basically one hardware to ThingSpeak cloud. So what we are going to do today, we are going to do this. So what is ThingSpeak basically? So we are going to see that practically now. So ThingSpeak is nothing but one server. It's a cloud server. From which company? It's from MATLAB. So MATLAB offers this ThingSpeak. Similarly, let's say Google offers, even Microsoft offers, their AWS offers, so they are different clouds. So I'm choosing this is little easy initially for you. So interface NodeMCU or ESP32, whatever, to ThingSpeak cloud. This is what we want to do. So to do this, what we have to do? We have to do two important things. So we have to first what? Create. So we'll see from cloud side. Cloud cloud side what we have to do. And second thing we have to see device side. So I hope it is clear. So what you wanted to do, you wanted to interface one node MCU hardware to one cloud. Okay. So you want this device to be connected. So you want this device, let's say this device, to this device sensor is connected or not, we will see later. That's not a problem. So the initially intention is this device should be connected to the cloud. Okay, this is what we want. Now this device is connected to the cloud, then what we have to do for that, you have to do something at the cloud side, and also you have to do something at the device side. That is the first thing. Now we will see this first, this connection is working or not. Now once this connection is working, what you have to do later, you can add sensor to this device, and this sensor will measure the data and push this to the server. Okay, that is the intention. Any doubt here? Over to participants. So I'm trying to set the agenda first. So the agenda first is you have to interface ESP32 or a node MCU to one server, cloud server called ThingSpeak. So interfacing is nothing but you want to push some data. But before to that, you have to establish connection. So to establish a connection between where device and your server, you have to configure your server and you have to configure your device. These two things you have to do. When device is configured, server is configured, they establish a communication connection between them. So for that, you have to use a gateway in between. Obviously, that we'll see. Now, once these things are working and connection is working well, then what is the next thing you have to do? Add one device to this. Okay. And then add a device. The device here is a sensor, basically. Add a sensor to this device and then push the data to the cloud. Any doubt in this? Over to participants. I'll just take small pauses to answer your questions if you have any. Any questions? All right. So let's go ahead. So having said that, what we are going to do now from cloud side, what we should do. Let's try to see. So this is what I have written here. So to interface node MCU to cloud, or interface is the wrong word, I can say, to connect basically. To connect node MCU to the ThingSpeak cloud. We have to do some changes in the cloud side and server side. Setting cloud side and setting we have to do at server side. Now what cloud side we will do first, we will see this. Okay. We have to see what we have to do at the cloud side. All right. So first from the cloud side, what we have to do. So we have to create an account. Create account in ThingSpeak. What you have to do first thing, you have to create one account in the cloud. What is the first thing you're going to do? Create an account in the ThingSpeak. So I'll show you how to create an account. After creating an account, you have to do two things. You will get one information of channel. So, and then you will have to configure your field. Very simple. Don't feel it's like very simple. But just you have to play with some buttons. That's all. So you have to configure what? Create an account and give a name to channel. So there is one option called channel. You have to give a name and then give a name to field. So there are two things you have to do. So give a name to the channel, give a name to the field. At last, one last thing you have to do is note. So note write API. These are the things. So it is already available. Don't worry, I will show you all this. So from the cloud side, what you have to do, create an account, give a name to the channel, give a name to the field, give a name to the field, give a name to the field. Okay. Give a name to the field, give a name to the field, and then you have to note the write API. So three things you have to do. create a channel, first thing, give a name to the channel, give a name to the field, and route out the right API. So these three things will help you. So these three things will help you to push the data. So that is the first thing you have to do. I'll show you. Now, from the device side, what you have to do. From the device side, first thing you have to do, you have to keep ESP32 library. I'll show you what it is. You have to keep ESP32 library, and then you should know SSID basically is nothing but router ID, which you are using at your home, or basically your hotspot also. Your hotspot. Let's say you're using mobile. Hotspot. Your mobile, if you're using, hotspot name is called SSID. If you are using your home router, that is your ID and password. So your password that you know. Okay. SSID and password. So with this, actually, with these three things, you can connect. These three things will help you to connect. So till this, it is connection. It's only for, this is for connection. Connection to cloud. So this is for connection to cloud. But if you want to push the data to cloud, what you have to do? This is connection to cloud. Push data to, if you want to push the sensor data to the cloud, if you want to do this, so let me just put it. Okay. So this is nothing but what? This is nothing but connecting to the cloud. So to connecting to the cloud, in fact, it doesn't even require this. This three is not required. Just create an account, you can connect. But basically to push the data to the cloud, push the sensor data to the cloud, what you have to know? You should know these three things. You should know name of the channel where you want to push. You should know field name where you want to push. And these are unique, by the way. It's a unique for every device and the right. These three things will use for pushing the data, not for connecting the data. Okay. So this is what you have to do. So let me summarize again. What we have to do. So we have one server, cloud server called ThingSpeak. To this ThingSpeak, we want to connect a device. So to connect a device, what you have to, step one, connect a device. Step two, connect a sensor to the device so that it will push the data to the cloud. So connecting sensor to the device is a second step that we'll see. But the first step is to have a communication between both of them. So to have a communication between both of them, you have to do some changes in the cloud side. You have to do some changes on the device side. So what changes you have to do? Configuration you have to do. Basically, technically, what we call it is a provisioning. So technical term, what is used here is called, you have to provision your cloud and provision your device. That's a technical word used for that. All that. So having said that, for provisioning, what it required? So I required creating an account, giving a name to the channel, giving a name to the field, and by default, you will have a right API. If you want to change, you can change it by clicking the button. It is simple. You can do this. And then to connect to the cloud, what you have to do from the device side, you have to know, you should have a library, hardware library. You should know the SSID and password. If these three things are there, you can connect first. And later, when you integrate a sensor to the device or interface a sensor to the device, you require this channel information, field information, right? All this, if you have, then successfully you can push the data. Any question to the participants? Over to you. Over to participants. Any question? Okay. Hope voice is audible, screen is visible so far.
Yes, sir.
So,
Yes, sir, it's audible.
Yeah. So before going ahead, I just want to give you one heads up. So what is that heads up? I'll tell you. So maybe I will just deviate for next maybe 2 to 3 minutes from the topic because this is more important, I believe. So I'll just deviate for 2 to 3 minutes and I'll come back to the point. See, always remember two things, because why I'm telling you, this is something which I learned from my past lot of experiences. And if you want, I can share you one such experience also. So, what I believe personally, whatever I'm teaching you, honestly, you will get in net also. For that, I doesn't require. Maybe I'm just giving you very initial stages. You can learn by your own also. But what you can't learn by your own, that I will tell you. So just be patient for next 5 minutes. I know I'm deviating from the topic, but I am really sure that my words will really help you when you actually do. If you're only attending a webinar, that's okay. But when you actually start doing it, what problem you will face, I will tell you now. Just be little patient. Number point one. See, always remember one thing. Whenever you work with the hardware, whenever you work with the students, there are two things I personally recommend. Number one, when you guide a project, always remember, create a faith in the student that my professor knows that. It is not always you're telling you do this, you do that, why it is not working, because that pain you don't know. If students are buying a project, that's a different story altogether. I don't want to get into that. But if your students are sincere and they are working with you and you're guiding them, always remember you should be one step ahead than them. Because whenever they come with you with a doubt, you should understand their pain point. It is very simple to say that, okay, why it is not working, how it is not working, but it is very difficult to sit with them and solve the problem. So if you want to be a role model, point number one, you should do, later tell them to do. That is very, very important thing. Number two, always remember when you work with the technical, the things are not very, very easy, just like a walk kick. You have to really understand that for some lines, you have to spend some days to solve. So let me give you one example of my past, and then I will come back to the point. So there was a project which we were working. So I just, why I'm telling you, this is what I feel is more relevant at this point of time. And I'll tell you what. So there was one project actually we were building. So that the project will have a nearly 60,000 detectors connected to it. So I'll repeat, nearly 60,000 detectors are connected to the panel. One device is there called panel. To that 60,000 detectors are connected. Detectors are nothing but sensors are connected. So what we felt that connecting all 60,000 in testing is really not possible. It's really not possible. Then what we have designed. So me and my friend traveled to Spain, and with our Western colleagues, we sat and we designed one application. So in that application, what we did is, this is called simulation software application. All 60,000 load testing you can do. So any application want to do the load testing, full load testing, like 60,000 devices to turn on and see my application is crashing or not. So to facilitate that, we have designed one application. So this is called one helper application for them. And me and my friend traveled to Spain and we did all this and we designed it. Okay, well. Then we came back to India. And then what we did is we gave it to a team and we asked them to test. And they were testing. Happily, it is working. 1 month went. Every day it is working, no issue at all. But one fine day, we got one Windows update. Now, please listen. This is very something you can learn from this example. We got a Windows update, and it's a company level update, so we did an update. Then what happened? Next day, the one who is using my application, he came to me and saying that when I'm running your application, my system is getting badly hanged. It is not even allowing me to press a key. Then initially I said, it's okay, you try, I'll come back because I was busy. But immediately my manager next day pinged me and told me, no, it's a very high priority because all the applications are waiting for this application to run. And whenever their applications are working very well, no problem. But whenever they are launching my application, entire system is getting high. It's not, they have to restart their system. So it's a high priority. You have to take it up. Okay. So with this, what I did is, okay, so I went and I now have to diagnose what is an issue. So initially, I asked them when you started facing a problem. He said that we got a Windows update recently. Now, when I was discussing with the team, my manager said that, okay, if it is a Windows update problem, also we don't know. So what we have to do, we have to take one older laptop. I want everyone to listen. Take one old laptop with that Windows environment and test whether the application is working or not. And take a new laptop with the new Windows version and see whether the application is working or not. In this direction, better you take 3 days if you can. Okay, I said fine. Hope my voice is audible to everyone. All right, I'm just checking in between. Is it clear?
Yes, sir.
Anyone can? Yeah. So now you may think that I'm diverting. I will tell you what is the pain. I will tell you. So I said, fine, 3 days at least. I need to understand this issue. So the point went such a way that so I have to test. Then somehow I felt that no. I think I'm going in a wrong direction. I have to take old laptop. I have to take a new laptop. I have to take old OS. I have to take a new OS and bang my head. I said no. I'm not going in this direction. So I decided to go in another direction. What was the direction I felt is? So I asked my teammate, you run that application in front of me. And that's in Linux environment. He ran the application. When he was running the application, I asked him to press one command called top, TOP, top command. So the top command, basically what it do, it will tell you the CPU utilization, very simple, something like that. So we call it as a task manager, something like this task manager. So this shows you. So this is a task manager. So what this task manager is doing, you can see that if you go back and see, it is telling that CPU consumption of this application is how much, memory consumption of this application is how much. Like this, it will show. It will show you the CPU utilization, memory consumption. Similarly, that's how it is. Okay. If you want to see graphically also, you can see. So CPU is 14% now, memory is around 7.4%. So similarly, Ethernet connection, you can see graphically. So similarly, there is a command called top in the Linux. So I asked him to run the Linux top command. And I said that I want to see my application consumption. And I was really shocked to see that my application alone, I'll repeat, my application alone was taking 99% of CPU time. 99.2 to be point. And I was gone crazy that my application was taking 99.2 CPU time. Obviously, no other application will work. So there is no context switching is happening from my application. And something my application is behave little weird. Now my application, honestly telling, has around 40 files, nearly more than 30,000 lines of code. And now I need to understand from which line that problem is coming. And do you really think that it's that easy? Then there was a tool called WileGrind. I installed a tool called WileGrind and I started running my application. And I went to that line where the problem is encountered using that tool, which took me 5 minutes. So I ran the tool, I ran my application, and it went to that particular line and said that this is the line where the CPU is getting stuck. Just what I did is I added a delay of 500 milliseconds. That's all. Because you have to give a breathing time to the CPU to do that. So I gave a breathing time 500 milliseconds, immediately started doing context switching. And my application, which was using 99.2 CPU time, came to 8%. All the application started working very well. It took me half an hour to solve this problem. So see, initially I thought to go with the OS update, but later I said, no, that direction is wrong. And I decided to go in another direction first. And in this direction, I decided to run top and C. And then from CPU, I went to the level of understanding which line. From which line, I added a sleep. And since the context switching is happening, the problem is resolved. And from last 8 months, this application is working very well. Now, why I'm giving you this example? This is something you have to understand called debugging skills. That is the most important thing, more important than when it is working. Always remember, when the things are working, you can learn nothing. But things are not working, you will learn many things. That is where you have to sit with your students. That's where your expertise will help them to solve. And when you solve along with them their problem, trust me, that is where you will get a credibility. That's where the student will start telling that my professor knows. So for that, I know you will be having a lot of burden, but you have to do that actually. I'm sorry, I deviated from my topic, but I felt this is very important for me to share with broader audience that debugging is the key point when you do a coding. And for that, I had one debugging session today. Let's see, because to be honest, when I started working with the device today in the afternoon, I see that issue and I didn't get a time to solve. If I get a time to solve, I will solve in front of you. Otherwise, we have to little bit deal with it. Okay, let's go ahead. So, all right, so far so good. So I have noted down this issue. This is the point. So now what we are going to do? So we have to do the crowd side setting. So for that, let me show you. So what you have to do, so first of all, I said you have to create an account in the ThinkSpeak. So go here and write ThinkSpeak. Now you'll get two options: sign in, log in. Sign in for the very first time, log in if you have already an account. So in my case, I have already an account. But if you want me to sign in with one of my ID, I can show you that. Let's see. Let's see if you, and let me see that it is configured. Okay. So I'm doing everything in front of you, and I know that the time may not be sufficient today. Let's see. So Wincar 2020 at the rate Gmail. So I decided to do this in front of you because, all right. So Wincar 2020 2022. This is one of my email ID, and it doesn't have a MATLAB account. So I just want to create it. So it says that, okay, so let's sign in. So I don't think so. It's not an invalid email ID. So what we have to do then? So go back and log in. We cannot do. So sign in, create a one. So we have to choose a create one because I don't have an account with this ID. So let me win 2022 at the rate. I want to create this account. And it is asking me the country. So let me give, yeah. And let me say Vinod and say Kumar. All right. So it's okay. It's not that easy. It will take some time. Okay. So it is saying use this email ID for the MathWorks account because it is saying that you can see personal email ID detected. I said fine. I know that these issues you will face. That's the reason why I decided to show this all. Sometimes you may face some issue. Otherwise, why to waste your time? I thought let us create an account. So, all right. So, email is sent to this. Okay, send an email to this link. Okay. So, what is saying? Verify. Well, all right. So, it is asking me to verify. So, what I will do is let me go here. By the way, just to show you, I have already a sign in account. It's not like I wanted to do this. I have already an account. If you want, I can show you. You can see. I have already this account. But I decided to show you this because there are some issues you may face. So, I felt it is better to show you. All right, so here is an email ID. They said that they have sent an email to me. So let's open and check it out. Okay, so let's go here. Okay, so I am not using this ID anymore. So I am going to use another ID. So got it. All right, so I have not added it. Then let me just try. Sorry if I forgot this email ID. If I don't remember password, I got this. I have to switch back. After a long time, I'm using this. I want to log in. Continue. Oh, my mind is working. Good. Okay, so I think I got a message to my mobile. Let me enter that. So let me check save. Okay. So okay. So they are saying so far so good. You have signed in. All right. That's great. Good to see. I'm able to log in here. And then what we can do is just find okay. Okay. So let me go to the Google account. Okay. Because I got a link there. Okay. So so what will happen basically? Okay, you can see this is okay. You will get one link. You have to click that link, verify your email ID. Okay, so you can see. Okay, you can see. Activate. Okay. So, so basically, how you'll get, I'll show you. Otherwise, if it is taking too much time, let me just show you once because I did just now. Okay, you can see verification. Yeah, verify email ID. You'll get. Okay. So now what you have to do, just verify this email. So I have verified my email. Okay. This is the check. Okay, this is this one. Okay. So I did verification of my email ID, and then what it will do is basically, so once you verify your email ID, from here you can do actually. So basically what you have to do, it will ask you whether your email ID is like you are a student, whether you're a professor and all that, blah, blah, blah. It will ask you some details, fill up those details and then send it across. You set your user ID and password. So once you set your user ID and password, you come back to this channel, something look like this. It will be something like this. So here you can see that you can create around 4 channels to best of my knowledge. I have created one. I will create one more in front of you. So let me create one channel with a name called here you can see. Okay, so this is my account already is there. So password. So I'm creating one channel here just to show you. So creating is sign in, create a new channel. This is something like so testing sensor. So I was telling you, right? Creating a channel here. So setting the cloud, what we have to do, create an account. We created an account, give a name to the channel. So I'm giving a name to the channel. What is the name I'm giving? Testing sensor. And then what you have to do, you have to give a name also. You have to give a name also. So field name you have to. Hold on, there it is. Okay, you have to give a field name description. So here you have description means you can ignore, but just testing sensors for demo. You can ignore this if you don't want, but here it's important. You can give oil master test. So something, this field name is very important, or simply as soil test. Easily you can do soil test. Soil test, something like this. So what do you mean by this? So at a time you can connect 8 fields, means 8 census value you can push through one code. That is the meaning of this. So you have a name of the field. So let me just capitalize properly. That's it. So name of the channel is test sensor and field name is soil test. You can give any name, whatever you can give up to 8 fields, means 8 census data you can push at a time. And then save this time. So this is one thing. Now what will happen? Whenever you push the data, your data you can see here. Here. Your sensor data will be visible here when the device is connected and it is pushing the data. Okay. And here is very important thing. You have to go and you have to see 2 things. This is called write API key. When you are writing to the application, and this is the read API key. I'll tell you when to use write and when to use read. Write API is nothing but you are pushing the data to the server. This is where you are using writing. The reading means you are reading from the server. Server here is ThingSpeak. So when your device is writing to the cloud, you are using this key. When your device is Can someone say you are able to hear me? Hope my voice is audible.
Yes, sir.
Yes, sir.
Okay. Thank you. Thank you. Thank you. Okay. So what did we do? Now you can see the channel is created 2 minutes ago. So here is the test name. All right. So any doubt till this? Over to participants. So this step we have covered. This. Any questions? Why the class is so silent? I get scared. You guys are following me, or I'm doing something which you don't know? Or do you want me to slow down a little bit? I can do that, not a big deal. Over to you guys. Any doubts, any problem? All right. So what did we do? We created an account, we created a channel, we created a field, and we now have even write API with us. This thing is done from the cloud side. So we are good to push the data. But before to pushing the data, we should connect. So what is the next step we are going to do? Let us write a code first. Okay. Any doubt till this? Because I just want to clarify if you have any doubts here. Over to you guys. Any doubt till this point? Because it doesn't make any sense. I'm going very forward and you're lacking somewhere in the between itself. Any doubts? You can clarify now. It's the right time. Else, I'll just take a pause and then go ahead. You can put even in the chat box if you're hesitant. No, sir. All right. Okay, so let's go ahead now. Next. So what I'm going to do then? So let us write the code. Now, what is the code we are going to write? So first thing, connecting to the cloud. Later we will push the data to the cloud. This code will write. There are two parts of the code. So first we have to write a code, connect the data to the cloud. Second one, what? Push the sensor data to the cloud. First connect to the cloud. This is step one. This is our step two. This is a step two. This is step two. Okay. In step one, these are the things we have to do. Keep your ESP32 library ready. You have to have your, this anyhow we'll see. There is an issue here. We'll see that SSID and password. So now you have to write a code basically. What I mean to write a code. Write code to connect node. This is what I mean in short. In step one, we are going to do this. Write a code to connect node MCU to cloud. Or even before connecting to ThingSpeak Cloud, write a connect to gateway. This is also much better we can do. Write a code to connect node MCU to the gateway. Gateway means what? Router at your home or mobile hotspot. Anything is, it's up to you. So you can use router at your home, whatever you're using, or you can use your hotspot. Anything you can use. Okay. It's up to you. This is your gateway. This is also called as access point. AP. Access point. So this will become your access point where your device is connected first to your network. Okay. So for this, what we required? What is required? User ID, and password. Okay. So user ID is also called as, okay, this is also called as SSID. This is called SSID and password. These two things are required. Okay. So any question till this? So required user ID and password. That is one thing we are going to do. Okay. So this is what we are going to do. So required. Now, what is the logic we are going to write here? So first, logic. Logic. What is the logic? Very simple. So the logic here is first what we will do. Very simple. So write a code to connect node MCU to your router. If you want to connect, first what you have to do, disconnect if something is connected. Disconnect if something is already connected, then connect. And check for connection. Is successful. That's all. Very simple. So I'll just show you that practically. Let's do that. So let's see. Okay. Okay. So let me just show you practically. Okay. Okay. Let's do that. Okay. So let's go to the site called TuneIOT. TuneIOT. So I'm just filming everything from here. So, TuneIOT. So yes, anyone, what we are going to do now? First thing we have to configure our access point. Our gateway, our device should connect to where? Our device should connect to where? It should connect to network. That is the first thing. First and the foremost thing it should do. Otherwise, nothing will happen. Okay. So I want everyone, you should play around with this option. So you can see there is an option called IoT. In this IoT, there is an option called station. Here, what you do first, you can see disconnect. The first thing what you are going to do, disconnect. Disconnect means what? If something is connected to my access point with this node earlier, that should get disconnected. That's the first thing. And then what? What it should do? First disconnect. And then you can make use of something like this. This is something what you can do. You can use this else statement, or there will be a lot of options. So you have to play around with this and just see what will be the right option for it. So something like this you can use. I'm just showing you the option. There are a lot of options like this. You can play around with this. You can see ThingSpeak is there, port is there, many things are there. So what we will do, first we will, okay, here you can see, okay, if you don't want, let me just delete this here. So let me just delete from here. Disconnect, and now I'm trying to connect. For connection, what is required? I require SSID and password. So what is my SSID? My mobile's SSID is Vinod. Mobile means my mobile username. And the password I kept here is I request participants please mute yourself. I can hear some sound. Pujita M. I request Pujita to could you please turn off your speaker? Okay, so what did I do? I disconnected it and I connected to this network. And then what I can do here is I can wait for some time. So basically what we can do is, let's say it got disconnected. We can see here. You can see that. And then you have to use this loop, repeat while. So what we can do is repeat while loop we can use. I request participants, could you please mute yourself? You can see here. So you will find below the rest of my knowledge here, because there are a lot of options we have to search through. This anyhow we are going to use, and then I request participants, could you please mute? Okay, let us see. So here we have connection and repeat while and do. So we have to see this option, repeat while. So I think we'll be in the loops we have to see. Repeat while or do we can do this as well, no problem. But I'm just actually I thought of showing you one option which is directly available. Okay, passport. Okay. I think we can just see here. Okay, if not, I think we can take, because this is important step. Because this is a new interface, I think it got little change than I used to work earlier. Okay, this is no. So repeat while and do. Can anyone see? And you can help me out if you can find it. Repeat while and do. So anyhow, we have configured this. That's not a problem. Let me just take a second. Okay. And here we have Arduino temperature sensor. Okay. If not, then we will take some other loop. Just give me a second because I want to be a little cautious here. Okay. Repeat one. Otherwise, we'll just take from here. This display. Okay. I think here. Advanced. No. Because this options got actually changed. Repeat one. Because they will be sometimes they are just placing here or there. So repeat while and do it is, I think, do while it is. Because I think we can use, but may not serve the actual purpose. Okay, so repeat while and repeat while. Okay, so this is the loop I just wanted to take because here. So is connected or not, we have to see. So here we have to see is connected or not. So you'll find this kind of thing. Just play around with this and you can just see the access point and just see it's connected or not. So here I'll just show you, otherwise we will code that, not a problem. Website, it's connected or not. Because actually there are some straightforward options earlier, and now I'm seeing after many years this site, and I could see there are a lot of changes. Repeat while, okay, it's connected or not. No. Just otherwise we'll take from here. Actually, we can take from here, but what will happen? It will be like clumsy. You have to take each one of them. It's not like something like this. Like this, you can take like one by one. You can do, but it's of like haptic, not is connected. You can take from here. Actually, there are some straightforward options. Example is connected. You will find it. Is connected like this. You have to drag each one. So there is earlier one loop directly. You can just drag and drop. Okay. So what you have to do? Disconnected. SSID and password and checking is connected or not. And then what you have to do here, you have to just wait for some time. And so better my suggestion here, you can add some delay. So delay you can add. That will, all the options will change. Okay. So earlier we have used delay, right? So let me just show. Not even. Okay. So we'll see somewhere if we have a delay, we can just take from there if you want.
I think it is in various, okay, in this. Because earlier the options were completely different. Now I think it was very straightforward last time when I worked it. So actually you'll find a delay here. Serial. Can you find something? No. Okay. I think we have recently also we used, right? Delay. No. Delay in milliseconds. It's not shown. It is actually should be here in the serial. Okay. Can you see somewhere here? Because all the options when I used to work was completely different than now. It is. Okay, let me try it once. Okay, but anyhow, actually without delay we can do, but I don't suggest you. Okay, here it is. Got it. Okay, here what we'll do, we'll wait for not 1 second, we'll just wait for 300 or 400 milliseconds. So what it is. So basically, sorry, it's taking time because the options are completely different. Even I have to scroll here. So basically, you're disconnecting from the network and then connecting with this user ID and the password, and then you're checking whether it is connected or not. If not, you're waiting. And my suggestion for you, always remember, better you add one new line message saying that waiting the device to connect. Waiting device to connect, or waiting
waiting for a device to waiting device waiting for the device to connect. This is something you can do. Okay. So what did we do? Very simple. You initially disconnected, then connected with this SSID and password. Is connected, you are checking. If not, wait. Otherwise, if you don't add delay, it will keep bombarding the network. And if your service provider is having a denial of service attack, it will directly go into denial of service attack. It will think it's a threat. So my suggestion, better you add some delay. Otherwise, it will consider it as a threat, because your router will also have a DOS attack algorithm to detect. If you don't add, it will think it is a DOS attack. Like everyone, if someone is trying very frequently, and within 1 millisecond, it may, I don't know, it will malfunction. So better add some delay. And then waiting for the device to connect. If it is not connected, every 400 millisecond, you can 4 millisecond, you can see it's keep giving you this message, waiting for device to connect, waiting for device. Once it is successful, then what you can do, you can take one more message here, you can type successfully connected. Successfully connected to. So your device is working like an access. Okay, this is the logic. Any doubt? So what did we do? So we have set up disconnect and then connect. Is connected, we are checking. If it is yes, then waiting for your device to connect and keep trying. If it is connected, come out and successfully connect. So that's the first step. This should show you the message. So we'll just go to code and then take this. Now there is a problem here that I'll tell you. Okay. So let us try with this first component. Let's try. So there are 3 to 4 things you have to do. I will tell you each one of them. It is not as simple what you are seeing on the board. Behind this, there are some logics are running that I will tell you. Okay, one such issue has come. Okay, done compiling. So it is compiled successfully. Now what we have to do? Let's try to. Let's say it's getting uploaded. If it is not getting uploaded, I'll tell you there will be 2 places where you have to tap. Okay. Okay, it's time to connect. You can see here it is showing some logs. Serial, that's a port number 4, it is detected. Okay. So when the uploading happened successfully, then it will try to connect to the access point. Let me turn on my mobile to see the access point is available. My mobile hotspot is on. Okay, timeout waiting for the packet header. Okay. So what you will do, always remember here, this is important. So it is configured. Always remember, you have to configure this thing. What it is, always remember. So here, I'll just show you if you guys are working very first time with ESP32. 2 things you have to do. So first thing, you go to internet and search like this. I'll show you something. Okay. ESP32 to, you can see ThinkSpeak. You can just browse it. And set, okay, beginner guide, beginners. So with this, what it will tell you, YouTube, you can follow, that's okay. But basically, very important thing is that settings. Okay, ESP32 settings. You can type like this also. It's up to you. So when the first step, what it will tell you is to copy this URL. Always remember. It will show you the pin diagram, which I shown you. And then you can see preferences. Go to preferences. And what it is telling here, you copy one link. Now, what is the link? It will provide you here also, you can see. So basically, if you go down, they will provide you one link, whatever I am trying to do. So, or you can say how to connect ESP32 to things. Okay, if you do like this, what it does is it will give you some step. First step is very, very important. So what it is, you can see. So what it is saying, this I'll come to this point later. What it is saying that if you go here slowly, you can see they will ask you channel, whatever I told you, right? Channel configuration. But I think they are not telling device name actually. Most of my you can see that because they are not configuring that. Okay, they are not telling at the device name. Okay, so better you can do now. I think you are not getting direct help from them. ESP32 JSON link. You can type because with now my experience will come into picture. Straightforward, some information is not available. So now with my experience, I'm telling you what you have to do is basically go here and search for this. Here you'll get. So they are the preferences and they're asking you to paste this link or this link. These two links also you can separate with comma. So this is important for your ESP32 to work. Okay, we will do both if you want, but I think this is enough. You can see that if you already have ESP32 board URL, you can separate it with this comma file. So this is something like this. You have to read them. If you want, I can keep that in chat also. Follow additional board URL manager. Here is very, very important. This is for ESP32 to work. So just you have to copy this from here. Always remember, this is important step. First, go to preference and copy. You'll get in the startup guide. So this is first thing you have to do. And then the second thing is that this library, what you're seeing now, it won't be there for you. So for that, what you have to do is go to tools, go to boards, board manager. These two things, if you won't do, it won't work. So now you may ask, sir, how I should know? No worries, you will have a lot of support in internet. Many people are there to support you, or this ESP32. You can type. So in my case, you can see it's already installed. In your case, it won't be installed. You have to, other than update, you will get an option called install here. Just install. Then this library will work. Otherwise, this library will show you compilation. Okay. So what is the step number 1? Now, what I told you here, just see with our notepad. Here, this will come into picture. So now here, what you have to do? So keep ESP32 library ready. This is what I meant to say. This is a step. SSID password, we have already had a code. This is important. We have configured our library. This is you have to do everything for the very first time, not every time. Now that is issue is resolved. So I kept ESP32 library. So that is the reason why it is compiled. Otherwise, it will not compile. So we'll have one more final check. You can see if it is not detected the library, the color will be in black in color and it will not compile. That is the indication. It will not compile and this library will be black in color, just like this. That means that the library is not detected. Can someone tell me why this library we are adding? Any idea? Any CSC faculty? Can I expect answer from you? Why you are adding a library? Anyone?
Then only the program is inserted in this Arduino board. That's why we are using this header file. It's a library file.
No. Okay, let me ask you one question. For all CSC, especially faculty, why do we write a header file? Anyone in the class? Why do we write a header file? Studio.h, Conio.h, math.h, you have in C basic library. Why do you write that library? Very simple question. Why do you write a library? In C program, I'm saying, forget about this, you leave it. Studio.h, why do you write that? Anyone?
Sir, as it contains the all functions of the all, so no need to write all functions from the beginning, basic functions.
Okay, good. So basically, let us say you want to perform addition in your program. You have two choices. Either you write it or someone has already written, use it. Correct? So I want to do ABCD in my program. In that, I want to do addition. So what I want to do, I will write my code, but for addition also, I should write a code. Instead of that, someone has already written. They will give you as a header file. You can use it. Of course, there are a lot of other things. I'm not going into the detail of C. Here, understand that if you want to check this Wi-Fi status, there is a code written. There is a code written. For Wi-Fi beginning, there is a code written. There is a function written which takes SSID password as an argument. For Wi-Fi disconnect also, there is a code written. So please understand, for Wi-Fi disconnect, there is a C code written behind. And for Wi-Fi begin also, there is a code written. For Wi-Fi status also, there is a code written. All these code are written in one place, given to you as a library. Just you can pass to this function, and that function will give you whether it is connected or not. Otherwise, you don't want to use this library. Next option left to you. You write a code for Wi-Fi disconnect. You write a code for Wi-Fi begin. You write a code for Wi-Fi status. You should write a code. And now you will end up writing that code which is not required for you. Your job is to connect, not to write a code for connect. You want your device to get connected and check. So that is the reason why the library is given. Got it? Now this library having these APIs. This is called APIs. API means, I hope you know that. These are called basically APIs. Application Programming Interface. So these APIs they have given you. You are using this API with your information. Got it? Now, if this library is not installed, this APIs will not get detected. Therefore, it will throw you compilation problem. In my case, since this library was installed. Now, how I install this library? So to install this library, that's what I say. Go here, preferences. First, you type this JSON link. This is important. And second step, go to this tool. And then what you have to go in the tools, go to board, go to board manager here. And then here you have to search for ESP32. And trust me, the way I'm telling you, it is not that easy if you do by your own for the very first time. ESP32. That's all. So you can see it's installed. And for you, just to inform you, there are a lot of ESP32 library. You have to find the right one. That also you have to spend some time because there are a lot of libraries are written, not one or two. Okay, there's another way you can add that if you want, I can just show you, but it's okay. I think that's fine. If you want, there's another way also you can add. Okay, so far so good. So my library is compiling. Now what next? I want to detect my board first. So here I can see that dev board ESP32 board. Okay, so let me try with another board. I don't know whether the board issue is there or not. Let me just give it a try. Okay, so I am adding another board here. Let's give it a try. Because I told you, I am doing this debugging little bit in front of you, which I had done earlier also, but there are two reasons. Number one, to be honest, I was very busy today in my meetings. Number two, I felt that if I do everything for you, you don't know the pain behind the screen. So I felt let us do in front of you sometime so that you guys can also understand how to debug. Okay, I've connected another board and let's say it. And I think the COM port, what it is detected, I'm not sure whether it's what it is. Okay, by the way, how to check the COM port? Okay, so here, please understand, this is also important because if you're doing device manager, for the very first time, you don't know because it is now showing 3-4 COM ports. I don't know which COM port it is. And then go to device manager, check the COM port. UART, you can see. Here it's UART. I will remove this and check. Is it the same board? You can see that, yeah, 3 went off. I connected again. Yeah, 3. So my device is 3. That's all, because now it is showing me 3, right? So my device COM port is 3. Good. And my device selection is here, WROM. Okay, my device selection is not WROM. Okay, so I feel this should load now. Let's see, I don't know. Maybe some other challenges, let's see. Oops. So what it is throwing now? So compilation board ESP32 deployed internal or external. I think it has to be updated or not. Okay, so let's see. All right, let me just give this a try. Or this one more, or otherwise we'll have one more last. We'll just update our MC. Let's try to do this. Now you can see that. You see this library is not working. You can see it became black. It became black. Means this device is not detecting this library. So this device is not detecting this library, you can see. Because I have actually another device with me right now. I changed the device. So you can see that this device is not configured for this LED detection. I mean this library detection. So I left with option to change the device and remove this. That's what I was telling you. This kind of issues also you may face. So I'm connecting the old device only because the new device which I connected is not recognizing that header file. I connected my old device and sorry if I'm taking your time, otherwise I have no option. Okay, so let's see. Okay, I am doing this. Now let me just first compile because my board is wrongly configured. WROM, I think it will not detect. Okay, WROM DA, it won't be. So I should do more to Node MCU. You guys have to do Node MCU. Yes, okay, here is the device. So you can see there are a lot of devices here. We have to figure out the right one. You can see on top also we have many devices. Okay, so I have to pick up the right, otherwise. So can you see Node MC anyone? Just you can have a look parallelly with me when I'm scrolling. Node 32 Node MCU. Okay, yeah, here it is. Node MCU ESP E12. Okay, so now you can see it's working. And with this, it is working. So that's what. So you have to be very careful with this. So sorry, I think I would have configured this earlier, but I really didn't get a time. So if this get loaded, I think it should, then it's connected to it. So we are just one step behind. Compile and dump. So variable constant RAM, okay, this is showing some RAM configuration, okay, don't need this RAM, okay. And while loading, I don't know why it is showing problems. It's compiling properly. So if it won't loading. So say, all right, that's good. So 23%, 30%, that's great, 38%, 46, 53, 61. And let's switch on to the monitor. Let's let it complete 100%. All right, that's great. And let's go to the monitor, serial monitor. Hey, you can see waiting for the device to get connected. You can see that it's trying now, the message which I have given. So, oops, I think my hotspot need to be reconnected. Let me just check my hotspot. It's on or off. Okay, so I'm turning off and turning on it again. So when it gets connected, waiting for the device to connect, it will turn into device get successfully connected. That message show you that it connected successfully. Okay, still, how long it is taking? It should not take that long. So I think let me check my SSID and password whether I configured properly. Hey, we did a mistake. It's Vinod hotspot. I beg your pardon for that. It's my mistake, my bad. So it's like Vinod hotspot, something I configured. That's the reason why it is not detected. And by the way, there should be some timeout. We didn't do that. There should be some timeout after these many tries. It should say that, sorry, there is no Wi-Fi available. So that type of error handling we should take care as a developer. But by the way, I didn't do that because it's only an introduction. But if I write a real-time code, I will definitely have a timeout. It will try for a certain amount of time and then say, no, the Wi-Fi is not available. Because of security reason, it has to go off. All right, so let's go ahead and see what's this. All right. Now, nothing else. It has to. So this is a level 1 test we are doing. Because if this doesn't work, doesn't make any sense. We are attaching sensors and pushing the data and seeing in the cloud. This should work first. Okay, so otherwise, if it doesn't work, then I left with one choice to rename my device to a very simple name because we don't know anything is like case sensitive here. HOT SPOT correct. Okay, password is let me check password is correct. 1 2 3 4 5 6 7 8. 1 2 3 4 5 6 7 8. That's correct. Okay, let me do one thing. I'm just changing this to I just make it simple. And I'm changing this also in my hotspot by the way. Just to tell you what I'm doing with my mobile. I'm doing this because I don't know if it is case sensitive or what because and one more bad, my networks actually is 15% my mobile and I really don't know with this it is allowing me to share my hotspot also. Can be another issue. If not, then I have to connect. And sorry, I cannot connect my router because I can't share my router password in the meeting itself. So that's the reason why I'm not doing that. Then if not, let me just check. Because it is my mobile percentage is around 9 or 10. So maybe because of that, my hotspot internally got shut off. Can be one of that reason. So just stay tuned. Let me bring another mobile with some good percentage. Just give me. Just. So I'm connecting charger by the way. And meantime, let me check if it is allowing. If not, just give me a second. I'll do one thing. I will fetch another mobile and then I will try to connect because I think 9-10% hotspot may not work. Just okay, so I'm back with another mobile in my hand. So let me just open the hotspot for this. Yeah, so just give me a second and just configure it. Okay, so I'm just opening the hotspot of the another mobile and let me just rename it. Okay. Okay. Sorry. So I have another hotspot right now with me, and let me just try to connect. Oh, okay. You can see what successfully connected. So the point to learn is when my mobile charging is less than 10%, I should not turn on my hotspot. That's the reason why. That's the point. Hope it is clear to everyone. Anyone, any doubt? Why so silent? Okay, so One last thing I want to ask you guys. So now we have successfully connected. Okay. The next step lies to us is connect to the ThingSpeak, and then we have to also configure what? One sensor. It will take 10, maximum 15 minutes, maximum 10 to 15. By 9:20 within that we can close. If you are interested, I can show them. If not, I can stop here. I have logged in 15 minutes late, I know. One step just one step behind to push the data to the server. If you guys agree, I can do that for you, no problem. If not, let
Yes,
me know.
sir. Yes, sir. We are interested, sir.
Okay, at least 5-10 students, maybe 5-10 participants. Sorry, I can
Yes, sir.
understand
We
one
are
or two.
interested. Yes, sir. We are interested. Please continue, sir.
Thank you. That's great. Okay, so far you guys can see now what we did is okay. Just roll back to our one point of discussion. So what we did is here. I'm sorry, I'm very bad in writing all this. Okay, so we were able to keep the ESP32 library ready. We keep hotspot ready. We keep the password ready, and connected and check the connection is successful. So we were able to see the device got successfully connected. Now what else we have to do? Now let us push the data to the server. Okay, so this is what we did. Now you can see there is a logic. Very simple. This is written here. For this, I require 3 things you can see. So I'll just go here. This is I'm keeping for a reference because the options got changed. So I don't really want to bang my head around it. Okay, so let's go to Tonight and let me open this Impala. Okay, so where it is. Okay, Tonight. Sorry. Okay, so let me go to blocks. This I'm keeping here and this I'm keeping here. Okay. Why? Because because the option got changed and really don't know where to search all these new options. Okay, so far we did this. Now what we have to do then? So go to once here, once again the IoT station you can find, IoT access scan, server. Let's see where they put this option. Okay, 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 okay. Go down, go down. No, ThingSpeak. Okay, here it will be. So we have to now have here API IT field and fine. I think this should work fine for us. Okay, good. So I'm going to take this. So you can see thingspeak.com is there already. That ThingSpeak website is configured. 80 port number is configured. Sending to ThingSpeak key. Here field name and value you have to just see here. This is the only thing you have to pass. Value and key. So what is this send ThingSpeak a key? So if you remember what I told you, you have to have a write API key. If you remember what I told you, you have to write here, write API key, field a name, and the value what to write, I will tell you, don't worry. So here you can see that I'm going here, and let me go to the key. Let me copy this right key. And let me copy this from here. Oopsie, I'm sorry. Just copy this from here, and then go here, paste it. That's it. So far, so good. Field name. So what is my field name? This is my field. Always remember, don't type. My suggestion, copy it. Otherwise, you will end up by doing another mistake. This is the field name. I know what value. This value technically should come from sensor. This should come from sensor. So meantime, what we can do, we can have a random generator between, let's say 0 to 100. So we can use, here we have to actually interface a sensor now. But I'll prefer meantime, so a random generator will be there. So functions, let's see here, or in the options, no, math, we'll just see some option because as I told you, these options are different now. Okay, so we have to, there is a random generator. There is a random generator. So just see, there will be a random generator.
Sir, once check the maths.
Can someone help me? Yeah, in which options?
Math.
Math, it is there.
Yes, random number between 0 and 100.
Yeah. Okay. Thanks. Okay, let me just delete this and paste it. Okay, and then obviously we have to have some delay also. Just let me copy and let me paste it here, and we'll have some delay here. Say 1. Okay, So this is what we have. So it is going to generate a random value between 0 to 100 or 1000, whatever, or you can even say 500, not a problem. It's up to us. So let's do it. Okay, so 0 to 500 random value should, but here this should come from sensor, by the way. I'm not doing that. And some test is my field name. This is my ID key. This is a unique. That's how it will recognize this. And in this ID, there will be a lot of fields, as I told you. I can have many fields. For this particular field, I want to write this. So on and so forth. All right. So far, so good. So let me just copy this. Oops, not all. Just copy this and then go back and then just come here and then select all, paste it. So looks good. Okay, looks good. And let's upload and check. And then obviously the loading successful. Now you can see you will not see output on the monitor screen anything because I have not used a API which is actually downloading. So I'm writing, I'm not reading from the server. I have another function to read from the server. Then you can see the output is coming on the monitor. It won't come onto the screen now. It will be only onto the web application you can check. So compiling board. Okay, let me compile first. So next step, what we will do, we will push to server, we will read from the server. Then you can see on the screen here also, bidirectional you can see. That ends this session. So something is going bad. Okay, just give me a second. Let me just reconnect. Compilation board node is here. Correct terminal. I substitute this. Oh, so I got it. Maybe this library is not edited. I don't know. I think this library. Maybe no. Because okay. Okay, we'll do one thing. Just to see. The problem is not with this, so let me just do one thing. Just to see the problem with this device or with the library. I just want to isolate. I just want to compile this just with one header file. If there is no problem with the header file, then I will just keep one more line and just try to see this issue. So that we will isolate the problem from where the issue is coming. I don't know. Then if the issue is from here, we have to download this library and then it will work. That's all. So the problem is not with this library. The problem is somewhere with the device mode configuration itself. But why just now it worked, right? Did I do any changes there? No, I think. Okay. Let's do module series. Okay. So did I configure port properly? Let me just check. Home port 3. Okay, that seems good. Node MCU seems good. Hey, it's not getting powered on. Wait. No, I think the problem is with this device connection. No, device went bad. So device is not turning on. I don't know, just now it was working fine. So just give me a second. No, device is actually having an issue. I have another device. Give me a second. If not this, I'll try to. No, device is going bad. Something went bad in the device. It's not working. Okay, just give me a second. Let me search another device if I have here. Okay. Okay. Just give me a few seconds. So. Oh, I think I did that. Okay. So I'm sorry, this device was working just now and all of a sudden stopped working. And my bad is I don't have another device. Okay, so let me give last try. But it should not be this. I have not seen this something earlier. It was working just a few minutes before. Okay. So device is not working now. So I think we are just one step behind, just to show you the output, nothing else. To be honest, I have another device but for this device, library won't get detected. For this, I have another device. Let me try. But for this, I'm sure library won't get it. So let me try with this another device, which is actually ESP32. One is Node MCU. For ESP32, library is not good. I'll try. Otherwise, we can just take some questions. Here, ESP32. Because I have another device, but for this device, the libraries are not detecting. And for what your libraries are detecting, that is. Okay, we'll just give a final try. If not, then no problem. Meanwhile, anyhow, I have shown you one. Okay. This is a device I have, but I'm sure if I connect this device, library won't. So for this device, there is an issue with the library. And for the other device, the issue is with the device itself. Okay, last try I will give. Let me see that if I can get. Okay, anyhow, I will show you one last debugging. We'll try for next 2 minutes. If it works, that's fine. So I can show you this also. In this way, you can search if you want. ESP32W ROM. What is that library name? ESP32 Wi-Fi library. You can search like this also if you want. There's another way of doing it. Library. Okay. If I can get this library like this, I think it's okay. Okay, let us give this try. If it works, there's another way of downloading the library. I'll show you if it works. Otherwise, they can just stop you. I can't do it because my device went bad. I will just show you another way. So you can go to Sketches, Includes, zip file, and go to Downloads, download. And here we can just give another file. So I have added a library here. So if this library actually gets detected, this turn into green. Means this library is working. And I have to do this for at least few minutes to check which library is working. I'm just trying one or two. That's all. I think it won't come back because the color I can see. Yeah. Got it. So it won't work. So the point is, okay, so just to open my video and show you, it's last. Let me just show you the problem. So that you can, of course, that's sometimes happens. Okay, so the point is, you can see this is the ESP32 device which is working, but library having an issue, which it takes some time for me to resolve. And this is a device which we have just now connected. So if I remove this and connect this, this should have a red color initially. But just now it was having red color, but now you can see it's not turning on. So this device went bad. Now I don't have any third device with me in my step. If I have another device, I would have. So I'm sorry for that. But having said that, the only thing you have to just see the output, nothing else. Everything I did for you. The only thing what you will see is I have configured for you. Code is there in front of you. So this is the logic. That's it. So this is the logic. Nothing else. It will push the data and just one step back. I'm really feeling bad about it also because just one step back, I would have shown you the data here. So let me show you. The data will push here. You would have seen just the data coming onto the screen here. Here you will be seeing the data. The graph will goes up and down. The only just one step behind is the device is not working. If the device is working, you will see some graph is moving. That's how. That's all. So we are just one step. Almost we are 99% done. This device because of that we lost. So data is not moving. Otherwise it will move. All right. Any questions? So I'm sorry I have extended the class. Over to participants. Okay, over to participants. Any doubt? All right. So that's all. If you want to talk to me or any doubts, maybe I'm available for next few minutes, 1 or 2 minutes. I will stay, and those who want to log off, it's up to you. I will be here for next 2 minutes to answer your questions. If you have any people who are doing research, if you want to get any doubts, I'm here to help you out. Over to you guys. But one thing, just remember, we are almost there. Only one step. You can try that at your home. No problem. You'll get it within no time. Yeah, over to you. Any questions, any doubt, any researchers, any point you want to discuss with me? Hardware, software, whatever. No doubts?
No doubts.
Okay, then
Thank you, Vinod, for your valuable time and contribution. We look forward to more opportunities to learn from you in the future. Thank you once again.
yeah, thank you. Yeah, so I'm signing off. Thanks a lot.